There's a newly available e-commerce dataset with millions of Google Analytics records for the Google Merchant Store that's now loaded into BigQuery. In this lab, you will use this data to create an ML model that predicts whether a visitor will make a transaction or not. And we'll build this model using BigQuery ML. So let's get started. You will be using a new quick lab environment we created for you. So when you log into the quick lab, this is what you'll see. You see we have a temporary username and password as well as a GCP project ID created for you. So the first thing you want to do is to click on this button to open the Google console. Once you do, it will automatically create a project for you in GCP. And once it's ready, you just click on this first button here to copy the username, and you can use that to launch your GCP project in Google Console. You'll log in with the username and the password here. I did that earlier, and this is what I get. So this is the GCP console. First thing you want to do is to use this menu here to find BigQuery. So if I scroll down, it takes me to BigQuery, which is the first item under the Big Data menu. So click on BigQuery, just accept, and voila, we're ready to go. So BigQuery, as we said earlier, is a scalable data warehouse that runs in the cloud. It's now ready to take queries. And the first thing I want to do is to run this query. So in the lab, you'll just follow the steps here. First thing I want to do is to create a new data set. Let's go ahead and do that. So if I click on this project, this is my new GCP project that the Quick Lab created for me. So if you click on this new project, use this option to create a new data set. And then you name that new data set. And what we'll call it BQML_lab. Hit create data set, and you'll see that under my project, I now have a new data set with the name that I just gave it. So back to the lab. The next thing I want to do is to copy this query here, and I'll tell you what it does in a minute. So go back to BigQuery and paste that query in the query editor. Now hit run. So while it's running, let me explain what the query does. The query basically runs a select statement to select a subset of records. So here we're just pulling 10,000 records from that Google Analytics sample in BigQuery. And we pull only these 5 columns from the data: the label, the operating system, this flag, this Boolean flag called isMobile, the country, and number of page views. Label is very important here because label is the thing, the outcome we're trying to predict. And we subset the data between 1st of August 2016 and June 31st of 2017. Okay? So let's keep going with the lab. Next thing, before that, next thing I want to do is I want to save a view. Basically, I want to create a training data set that I will use to train this predictive model in BigQuery ML. So to do that, use this button called Save View. And you can give it a name. So I'll name it training_data. Voila. So it says data saved. So if I go under that data set, you'll see now that we have a new view called training data. So let's go back to the lab. Now we're ready to create a new model. So our first machine learning model in BigQuery using BigQuery ML. And to do that, if we go back to the query editor, click that button called Compose a New Query. So we start again from scratch. We'll create a new query. So I'll just paste this command. So let me hit run, and then I'll explain what it's doing. So this query is used to create a new machine learning model. So in this case, we call this machine learning model sample underscore model. So what is it doing? We have options, and the model type is logistic regression. We use logistic regression because effectively what we're trying to do here is to build a predictive model that does binary classification. Okay, so we're trying to remember what we're trying to do is want to build a model to predict whether a visitor will make a transaction or not. So that's a binary decision, and that's why the label we have here is basically Boolean. It's 0 or 1. So if it's 0 for a given row, it means this visitor did not make a transaction. If it's 1, it means this particular user actually made a transaction. So the algorithm we use to build that type of ML model is an algorithm that does binary classification. And in this case, in BigQuery ML, the most natural one, the logical algorithm to use is logistic regression. And then the last statement here basically runs a select statement from the training data we created. So basically, BigQML builds a logistic regression model using that training data view we created in the last step. And now it's ready. So under that data set, we now have a new item called a sample model. This is basically the trained model from BigQuery ML. If I click on it, I can see 3 tabs. There's a model details, model stats, and the model schema. Model details just tells you a summary of the model. So you see, it is a logistic regression model type, which is what we selected. The type of loss we optimize for is a mean log loss, and then it has other details of the parameters. I want to click on the second tab because this tells us a summary of the model training. So the first column is this thing called iterations. So when we train an ML model for classification, we're basically teaching the model by showing it the training set over and over again. And at the background, we're optimizing the error. We're optimizing the model to reduce the error. And so what you see here is 10 iterations of training. And the thing to watch are these 2 columns, the training loss and the evaluation data loss. Over time, as we train the model, the error should reduce. So the loss on the training set and the loss on the evaluation set should both reduce. And that is what we see here. You see the training data loss reduces from 0.5192 down to just under 0.0333 by the 10th iteration. Similarly, the loss on the evaluation set also drops from 0.5196 down to 0.0337 on the 10th iteration. So this tells me the model actually trained effectively, and we don't have overfitting here because the error on the evaluation set also reduced accordingly. So now we have a trained model. Let's go ahead and start using it. Or first, I want to evaluate it, and then we'll see how to use it. And we can evaluate it using this function from the lab. So I'll just copy that query, compose a new query again, and if I paste it, hit run. So let me explain what's going on. So in this select statement, we use this function called ml.evaluate. We're using it to evaluate this trained model we just created. And you see it will show you a number of important things. First, the precision, recall, and the accuracy. These are different performance metrics of your model, right? You use these to see if the model is actually a good model or not. Accuracy is very high here, 98.87%. The F1 score is not that high, but the log loss is very high and is consistent with what we saw earlier. The area under the ROC curve is also very high. This tells me this particular model does a good job of separating the two classes. That means it can predict which user will make a transaction and which user will not. So after the evaluation phase, the next thing is we can go ahead and start using this model. Let's use this query first. And with this query, if we come back, click on compose new query. If I paste that query, hit run, then let me explain what it's doing. Basically, we've created a new data set that we'll use to make predictions on the model. And so with this data set, we basically pull a different sample of data in the month of July 2017. You see, we're pulling data from 1st of July 2017 to 1st of August 2017. So 1 month of data for predictions. And in this case, we pull the same 5 features we had before. So the same 5 columns, plus 1 new column, which is the full visitor ID, because we'll use this visitor ID to make predictions at individual user level. Okay. The label is important because this label tells you what actually happened. So in machine learning, we call this the ground truth data. So for each particular user, we can tell whether they actually made a transaction or not. Did they actually purchase or not? Right? So if it's 0, it means in real life, the user actually purchased on that visit. If it's 0, sorry, the user did not purchase. If it's 1, it means the user actually purchased. So that is the ground truth. What we'll do is we'll use the machine learning model to make predictions for each of these users, right? And then we can compare their predictions to the actuals. But before that, I want to go ahead and save this view. And I'll label it July_data. Let's save it. So now you'll see that new view I just created with data we collected for the month of July 2017. So next, I'll go ahead and start testing the model. And the first thing I want to do is to predict purchases per country. We want to see, what are the top 10 countries that are predicted to have the highest purchases. So let me copy that query. I'll come back to GCP we go back to BigQuery and hit compose new query. We paste that, I'll paste that query in there and then hit run. So what it's doing is it uses that data, the data set I created for July, to make predictions for each individual, and then it aggregates it by country. So notice that in this case, we use this function called mlpredict to make predictions using this model, and we're making predictions using this test data we collected for the month of July 2017. Notice that this is different from, this predict call is different from the previous call we made. Before, we used ML evaluate to evaluate the model. Now we're using ML predict to make predictions for each user visit. Okay? And this is the result of the query. It basically shows you the top 10 countries who are predicted to purchase from our store. Okay. Another thing we could do is to use the same model to make individual predictions per user. Let's say we want to find out, hey, who will be my top 10 users, right? Which users are most likely to make a purchase? So if I paste that query, I hit run, we're using the same predict function again, ML predict function, to basically make predictions by individual user ID, right? And rank it. So we group by full visitor ID, and then we use the order by predicted purchases to rank it. And so this query basically gives us our top 10 predicted users. These are the top 10 users who are predicted by the model to make purchases. And so we've seen how very, very quickly in this lab you can use a sample of that Google Analytics data to build a predictive model using BigQuery ML, and the model can start to predict which user is most likely to make a purchase when they visit our website. Thank you very much for your time, and I hope you enjoyed the lab.